All right, so let's take a look at all the different types of testing that a QA engineer might take a look at, might consider. Now, as we've discussed this in earlier lectures, it's oftentimes easier to use the analogy of considering the application under test or feature under test using what is referred to as the box model, right? That we consider to be the feature itself, we consider to be some kind of box, and depending on how much access do we have to the internal workings of this box, then there are different strategies that we might use to test this box, right? Very much like what we already talked about. Black box testing usually means that there is whatever it is that we are testing, it's opaque to us, that we don't have visibility into the implementation of the feature. We don't know if they're using linked lists or arrays, or they're hitting some remote database that it's in NoSQL, or if it's relational. It's completely irrelevant to us. So the type of testing that we would apply here are those that are irrelevant, that makes it that we're considering that is irrelevant the actual implementation. Then you have gray box, where you do have some access to the somewhat what the implementation might be, and how that affects what testing you might do, right? You like to know that for certain implementation, for certain inputs, you would expect certain things to happen if it's implemented in a particular way, right? If you know that it is either a desktop application that needs no network access, right? Only uses the local file system, might be completely different if it's an application that is fully online and it's downloaded from some remote server and it has to go back and access RESTful applications, right? Even though it's the same identical application, same user interface, same behavior, right? But knowing that this is a desktop application fully running just with you looking at this, right? You're the only client. Is very different than the same identical application running online but serving thousands of people, thousands of folks, right? Same identical behavior, but one of them is fully running on your local machine, whereas opposed to the other one has to go back to some remote server and some remote database. And so the testing that you might define, or you might try to identify, is driven by this knowledge. Right, this is either a self-contained single application running for one simple user. Will have a completely different set of tests for something that is fully implemented remotely. Then there's white box testing, where the implementation, the for loops, and knowing that it's network, and knowing that is using JSON or XML, or knowing certain implementation idiosyncrasies. Informs what the tests are, right? And this is more what we've talked about when we talked about structural testing, that allows you to identify what your unit test might be, to make sure that all different paths are considered, right? That it might inform you with some edge cases that you didn't even consider, right? That to even add it to your test plan. So certainly white box testing can help you inform what your test might be. Now we can categorize some of these types of box testing for different types of testing that the QA engineer might do. For instance, the testing that QA engineers do, for instance, for doing manual testing or doing automated testing, those are both examples of black box testing, right? That they're going to look at the application, they're looking only at the user interface. They have no idea what's behind this, and they only have access to buttons and input fields and scroll bars and mouse and a keyboard, right? They have no access or need or care what's behind this. Same thing with automated tests. Automated tests are typically manual tests that have been converted, have been scripted, right, to be able to repeatedly implement these, run these otherwise manual tests. Again, by exercising the user interface, right, regardless of what's happening behind the scenes or how is this implemented, right? And usually this is the purpose of these types of black box types of tests is to identify if there are any issues with the functionality, right? If I click here, does it actually do this, right? If I click there, does it actually do that? Also the usability, right? On whether something is clearly explained, whether it might need some additional tooltips, whether it might need some additional help, support from the application. And typically these types of black box testing is solely performed by the QA engineer. Right? They're the ones who have the responsibility of implementing these types of black box tests. Then you have the gray box testing, where we do exercise the user interface, right? But we see how the internal behavior, what's happening in internal behavior. Maybe we even bring up the console, right? So to see that if we press a button, ooh, look at this! I see all these errors on the console. What's going on there? We might even look at some of the responses from the server, right, and see that the JSON that's coming back is what we expect. Right? So we go a little further, right, and see, oh well, we know that this is either a local application running just locally, and we look at the files maybe that are being written, or we see some of the records that are being written to the database. So we go further, right, and see that the behavior is working throughout the entire stack, right? And so these are typically implemented by both. Oftentimes we refer to this as integration tests, right? Where not only do we consider one of the layers of the implementation of the application, but several of the layers, right? How does clicking on this button affect some other layers of the application? Oftentimes this is implemented by both, either QA engineers and developers, either working together or independently. If it's by developers, typically they will be using tools such as Jest, right, or Mockito, or some of these, or Karma or Jasmine. These tools that are part of their build, part of their running these tests, independently from their desktops. And letting them know that to verify that when I do click this button, right, I do get these inputs back, right? And we looked at some of this last week when we looked at Jest. But QA engineers also do these types of implementation, but perhaps using other tools, right? Not developer tools, right? Typically they might use tools such as Selenium, and also exercise the user interface, right? But not from the DOM. Not by accessing directly to the DOM, but simulating actual clicks, simulating actual drags and keyboard inputs, the actual interacting with the actual window of the application, and then doing similar tests of checking to see if the data is being inserted or removed, or whatever data transformations are being executed. For the white box testing, this is more what we've come to understand ourselves as, the developer has full knowledge of the code, and they know that they've used these for loops and these if statements, and they know what the actual algorithms that they have implemented, right? And they might implement unit tests and also structural tests, right, to identify what the edge cases might be for us to better implement their unit tests. And usually this is solely the responsibility of the developer, right? Where they're using JUnit, right, and running some structural tests to inform better unit tests. Okay. So again, we're not going to spend too much time here on white box testing since we've covered that in previous lecture. Let's consider the other two. So here's an example of taking, considering the same use cases that we looked at earlier, the same user stories of interacting with a shopping cart, and what would the test look like, right, from the point of view of the QA engineer. So, for instance, here we have some behaviors that we want to be able to have items being added or removed from a shopping cart, and also that the total quantity and also the total calculation of how much the shopping cart is, the cost or the value or the price of the total displayed. We want to verify that indeed that is being calculated correctly, as we add or remove different items of different quantities, adding or removing to the shopping cart. So we like to be able to generate a test plan for all these, right? So from the white box point of view, us developers, understanding the implementation of these of the algorithm, having access to the functions, having access to the data model, having access to how the data model is being manipulated, right? We might have a particular function that the responsibility is to increase the quantity of some item that is being added to a shopping cart. So we might write tests such as test the increase that calls a function under test, and then it verifies and asserts whether the value is what we expect. Right. So this is very much like what we're currently perhaps doing today in the current assignment. Right. White box testing and creating all these unit tests and coverage and whatnot. Right. Now from the point of view of a QA engineer, they might also want to test the integration testing, that they know that if they click a certain button or they navigate to a certain page, that there will be some RESTful calls that go out to a server, and they might want to verify that indeed that is actually working, right? If they know that's the implementation. If they know that instead this is not an online application, that this is a standalone application running locally on your machine, they'll know that this is not generating some RESTful applications, but perhaps accessing some local XML files or manipulating some local embedded database or some other file that is that can be accessed by the QA engineer. So they might exercise either manually or automated. They might exercise the action, right? They might simulate those actions and then verify whether the database was correctly updated, whether the JSON response was correct, whether there was successful a response of 200 or whatnot, or some structure of the data that is being returned. And if they in black box testing, this is exclusively from the point of view of the user interface, right? That we are interacting with the user interface. We don't really care or know or don't have access to whatever implementation is behind that user interface, right? That we only have access to the DOM perhaps, or that we have access to the screen that we can click or automatically click on the buttons and whatnot. And so here, for instance, we might use perhaps jQuery or some other technology to simulate user interaction, right? Where we are identifying a particular element on the screen, and that we are simulating those clicks, that we're navigating to a particular screen and whatnot, and then verifying that whatever quantity or whatever element on the screen has whatever we expect it to be, right? Without knowing what's behind the screen or even caring. So these would be the different types of testing that the QA engineer or ourselves would be implementing for quality assurance. Manual tests. The intent of the manual tests is for QA engineers to identify first what are all the different actions that users are expected to exercise, right? And creating a catalog of all these various actions, presumably they're from analyzing the use case analysis, right? Identifying all the user stories, and from these user stories and these use case analyses, coming up with the test plans, right? Given this and that and the expectations and whatnot, they would create all these acceptance tests, and then they would exercise them manually. Now, Jira, we haven't taken a look at Jira. Jira has a feature that test engineers can use to formally implement stories that are specific for tests. These would be test stories. We haven't looked at those that follow this structure, right? Given this, then that, right, and that and whatnot, right? And then they can check off and they can write all the different things that are expected, right? What the actual values are, whether it passed, whether it failed, right? And so Jira supports this jargon, supports these way of implementing these acceptance tests. We won't go that far, but nevertheless, just so you know, right, that this is fully supported by a lot of the tools that we've been taking a look at throughout the semester. But the test engineers is responsible for identifying what all the test scenarios are, what the typicals are, right? Where's the where does is the app the user where is the user using 80% of the application? Where is the bulk types of users using the bulk application? Where's 80% of the users using 80% of the application? I want to focus on that, right? And so that we can make sure that is solid. And then obviously identify what the rare cases are that might be perhaps less of a priority, that you might affect only a small population of the audience, and that might have maybe a low impact, right? Things that are sporadic that or even if they're broken, they might not stop the user from accomplishing their particular goal. Okay. So, for instance, a manual test example might be that from this flight. Imagine this were the use cases for a flight agency that you can, for instance, search for flights, that you can buy a flight, you can check their statuses. Ideally, at first, the test engineer would revisit all the use cases from the use case analysis early on, and brainstorm what are all the different scenarios that they want to test, right? That and there will be one scenario for each, one test plan for each one of the features. There will be many scenarios for each one of those features, and each one of those scenarios will have a happy path and a sad path. For instance, the happy path might be that you're going to search for a valid, one-way or a round-trip flight. So those are valid searches. And then, the sad path, identify, for instance, you might search for invalid routes that the flight, that particular airline does not cover, or destination and origin and destination being the same, and what the expectations might be. So as a QA engineer, I would keep track of all the different scenarios that are going to be manually tested, right, and what the expected results, and also the statistics on whether they were successfully accomplished or not. Oh, so this why is it doing that? Is it here? Present. Okay, that's better. So this is a list of all the scenarios that we're going to be testing, right, and the statistics on whether they have passed or failed, what the expected results are, and so they might have a really long catalog of what it is that they're going to be testing, and they also might have all the data that they're going to be inputting, right, whether for each one of the scenarios, the origin and destination, San Francisco ALX. When the dates that they depart, when they're returning, and some of the invalid tests, that routes that are not supported by the particular airline, or a route that is not supported, or whether you're flying to the same origin and same destination. Now, for in automated testing, the idea is that you want to be able to automate as much as possible, so that we can be confident that every time we introduce a new feature, that we haven't broken something that perhaps used to work but no longer works, right? That we want to identify any regressions, and that we can repeatedly do this without thinking about it, right? That they just run, and just like our unit tests, every time we do a Maven clean install, these run and they notify us if something is broken. Just same thing, right? The QA engineers want to do similar things, but instead of having access to our API, instead of having access to the DOM, instead of using Jest or Karma or Jasmine to be able to access the particular stack, they're going to want to exercise it from from the user interface point of view, right? Using some black box testing, they want to actually click the button and actually scroll and actually type at the user interface. So they need to be able to program some of these scripts so that they can automate some of the more complex aspects of this, such as being able to combine different frameworks, right? Whether this is either different operating systems, different browsers, and this could become combinatorially explosive, right? That you have to have 3 or 4 operating systems, 3 or 4 different browsers, and so it could get out of hand for this to be able to be done manually, right? So you want to be able to automate this and be able to target any of these different combinations, different versions of browsers, different vendors, different operating systems. It can get out of hand really quick. Usually these automations are done early on in the alongside with perhaps with the developer folks, in the build phase, and then they should be done by the time that we come around in the test phase, so that we can run this against what's being implemented. Now usually these user interfaces, automated user interfaces, usually they are fairly slow, right? They usually entail a framework that can instantiate a brand new browser or a brand new application. If it's a standalone application, it would need to be able to actually instantiate and run the application, right? And actually exercise it and click and navigate and see if it behaves. So it can be fairly computational intensive and also might take time, right? Because some of these actions might require folks to wait for certain behaviors to occur, right? Usually, if we're doing it manually, right, the application runs lightning fast, only because we are very slow, right? But nevertheless, especially if it's a remote application being hosted on some server, it means that it needs to download, go back to the server, do some asynchronous call, and maybe render the user interface dynamically, right? Again, for us human beings, the application might be just fine. Half a second might be nothing. But when you're talking about running hundreds of these tests, of having to instantiate this, and each one taking half a second, each action, they add up. So they tend to be fairly slow, and so we tend to only automate some of the more important workflows, right? The ones that are critical, that most of our users are going to be using, right? Where most of the traffic goes through, and that we want to make certain that those are valid, right? So they're pretty slow. They might be slow. So we might only, out of all the manual tests that we might have identified, we might only focus on a subset and say only these subset of all the scenarios we're going to automate, right? And keep track in our test plans which ones have been automated and which ones have not been automated. And for instance, here we've identified these 3 as being critical, right? We want to make certain that these are the happy paths, that we know that these work, right? Perhaps all the other ones might be edge cases where we don't cover a particular route, right? Or and ideally that would be the least likely workflows that would fail, right? And we want to make sure that the ones that are mostly used, that those certainly work, right? So we might focus on just these 3 as opposed to all 5 and automate all 5. And so, for instance, we might automate using all sorts of languages and all different frameworks, all different tools. There's all sorts of tools out there for automating these tests. We're going to be focusing on Selenium specifically, but certainly there's many other tools out there. Selenium is free, it's open source, and it works well with a particular stack that we've chosen for this course, right? Which is a web stack, right? But if this were a completely different stack, then it would be a completely different tool, right, for testing standalone applications using some other technology. Nevertheless, whatever tool you're using, whatever framework you end up using, there will be some scripting language right, that will allow the QA engineer to implement and automate their tests. So for instance, there might be functions that allow you to automate being able to search a one-way flight, or search a round-trip flight, or search the same origin and destination. So there were all these scripts that you've identified, right? They would be represented here. The language would be different. Oftentimes different languages are supported, for the different frameworks. Certainly Java usually is supported, Scala, Ruby. There's tons of languages that are supported that will allow you to implement it in your favorite framework. So in this particular case, here we're automating the interaction with a form that we're navigating to a particular form. We're grabbing a particular input field, and we're simulating typing into that field. And so two different fields, the origin and destination, San Francisco, ALX, and then also setting up the date of departure, and then clicking on a particular search button, and then looking at a particular field, whether it has a particular value that we would expect to be 10 in this case, right? Again, this will be completely different depending on what framework, whatever stack you end up using, but there will be something similar that would allow you to implement and create these automated tests. Right? Notice that this is very different to the type of automation that we implemented last week, where we were using jest to interact with the DOM. Right? Here we are interacting with the window, right? The window that we would instantiate an actual browser, right? And then actually click on the buttons, and they would highlight and they would hover as if we're a human being interacting with it, right? As opposed to what we looked at just last week, we weren't even using a browser, right? We were simulating the DOM that a browser would have generated, right? Whereas over here, we're fully integrating with the entire stack and the actual instantiation of the user rendering, of the user interface rendering. In the integration testing that we mentioned earlier, integration testing is a type of gray box testing where we have some knowledge of the implementation or the stack or the framework or the techniques or the architecture of the implemented application, and then we take advantage of that knowledge to drive some of the decisions of implementing our tests. In this particular case, we are aware that it's some web-related stack, that the technologies are HTML, and there's JavaScript in there, and that there's the DOM and whatnot, and that there's a middle tier layer that is listening to incoming RESTful services. So we kind of know what the architecture is, and that can drive, right, some of our decisions on what it is that we want to test, right? So this gray box testing can serve as an alternative, or as a companion, right, to the automated tests that we implement. So we decide to automate some of our manual tests, and having decided not to test some of the more long-running, or because they might be somewhat slow, we might instead of trying to automate all of these, knowing that some of these might be fairly slow, we might decide to instead apply integration testing for these two, right, and automated testing for the ones for these other three over here, and having decided that, having accepted the fact that we're not going to automate everything because it can be fairly slow, we'll do automated testing on the more critical ones, and the ones that are not as critical, we might do just integration testing, right, where we're going to hit the server, right, we're going to exercise the UI, but at the DOM level, right, kind of like what we do with Jest perhaps, and this will cause an HTML, an HTTP request, come back with a response, and then we can verify that the response was correct. Yes, but without actually exercising the entire browser, instantiating the entire application, right? Which might certainly render this very slow. Make sense? So the application. So all this strategy that certain things will be manual, certain things will be automated, certain things will be integration testing. So all this strategy, right, of what is that going to be manual and what is the combination of the different strategies is what would be captured in that original document I said at the beginning, right? In the testing strategy, which is the living document on how is that what's going to be the process of addressing all the QA effort. So, for instance, the integration test might entail, simulating an actual invocation to some remote RESTful API. That it's a post that we pass in the origin and destination, and then the response, where that comes back, we parse it out, we validate and check to see that indeed there are 10 flights that match that query, right? So again, a combination of doing this integration testing and some of the manual or automated testing. There's also performance testing that looks to see that or to check that the application is perhaps scalable, that it might work just fine if it's just me, interacting with the application. But when you put it out there, right, where you start having hundreds, thousands of folks, simultaneously using the application, then perhaps it's not going to work as well. Right? So we want to be able to capture these things as early as possible. Identify where the application, where it has some bottlenecks, some network traffic bottlenecks, some algorithm that could be implemented in a better way, and to see how it behaves over time, right? With a sustained effort, with a sustained load. So now there's quite a few different types of performance tests. There's certainly there's load tests. We want to make sure that we identify what is the maximum capacity that we can bring an application at, before it starts degrading, right? Also, endurance testing, load testing is see if the application has a particular capacity, but perhaps for a short amount of time. Can it sustain a peak 1,000 users all of a sudden hitting it at the same time, right? So that's what usually is referred to as load testing. Whereas endurance testing is we want to be able to exercise the application for a very long time, right? Where we might start identifying that there might be memory leaks, right? That over time, as objects are being instantiated and released, and objects are being instantiated again and released, as connections are being retrieved from the database and then they're being released and then asked again for a connection, to see if over time, right, the database degrades, whether there's memory leak. We see that the memory footprint is perhaps growing over time. And then there's also stress testing that we want to see if as the application is under stress, under load, what happens when we start removing some resources? What if the network goes down, right? What if the database goes down? What if if it's a round robin node, multi cluster, right? What happens if you add clusters? What if you remove clusters, right? Or machines in the same cluster, right? What happens as you remove resources? Maybe you have other applications running in the same machine. How does it degrade? How stable is it as resources start to run low, right? So so load testing, as I mentioned earlier, right? We want to see how the application behaves when we increase the request, or multiple users, thousands of users start to access it simultaneously. As we increase the number of simultaneous users, see how long does it take the application to respond, right? Does it degrade over time? That the more the users, the longer it takes, right? Oftentimes, depending how it's implemented, if it's a stateless application, usually stateless applications tend to scale much better, since the application doesn't need to remember anything about the particular users. But if it's a stateful application that folks are logging in and we have to maintain, large amounts of memory for each one of the users, then typically those footprint of memory starts to grow as users start to accumulate. Also, as a day changes over time, right? And at different times of the day, you might have a lot of load during the day, but then it goes down during the night, and you want to see what are all these max and mins, all these troughs and peaks that you see as the application adapts to the different load over the day. Endurance testing is that we look to put the application under load, but for long periods of time, right? That we want to see over a long extended period of time. We see if the CPU or the memory footprint or any of the resources starts to degrade over time. Any connections not being released, right? And the database perhaps at some point refusing a connection because it has too many open connections, right? So we're only going to identify these things if we exercise our applications over long periods of time. And then you have stress testing where you make it increasingly harder for the application and increasingly harder by removing resources, or removing memory, removing CPU, removing network, removing accesses to the database. How it behaves as you increase load and you interrupt internet or you have different resources misbehave, and see how the application is stable or can recover from these failures, and it's a measure of resilience on how the application behaves under these stressful conditions. The other types of testing is security testing, that we want to make sure that the application can handle all different types of security attacks, right? Whether it be denial of service, where you might have thousands of bogus requests coming in at the same time, so that the application starves legitimate queries, or folks trying to inject SQL into the fields to try to have access to data that is private information. So certainly we want to make sure that we test these aspects of the application. SQL injection is a technique that hackers use to in their input fields. They instead of providing what normally you would type as usernames and passwords and whatnot, they would embed inside of those queries SQL. That if your application is not designed correctly, you might take those strings literally and concatenate them and then execute them against your database, right? So oftentimes we seek to sanitize those queries, any strings that comes from any form that human inputs. We want to make sure that we sanitize them. We remove any extraneous characters that should not be part of the input that comes in from users. Denial of service is also a very common security concern, where hackers might bombard a server with bogus requests, so that the server is busy trying to serve bogus requests and is starving legitimate requests that can't get the service because the server is busy, answering all these bogus requests. Now, there's tons of tools that can automatically detect these kinds of queries and just ignore them, right? Or backup servers that are on standby that can, we can redirect some of this traffic so that we can serve the legitimate requests. GitHub also has a lot of tools that automatically scan your implementation, looking for these kinds of vulnerability, and it generates a report, right, on the types of vulnerability that it identifies, and then that suggests that you go back and fix